Hello, and I'm Lou Kerner, and welcome to the 16th Member Showcase of the Decentralized AI Agent Alliance. We started in January of 2025 with a mission to foster the development and proliferation of decentralized AI agents through education, activism, research, and events. And when we say events, we have two regular events a month. The first Monday of the month is our general meeting, and the third Monday of the month is our member showcase, and that's what today is. And we've got three great members who are each going to present individually, and then they're going to, I think, present collectively. And is that right, Eric? Awesome. I'll be turning the floor over to them shortly. But first, we'll go over some membership stats, membership introductions, and membership updates. I'll give some brief DAIAA updates, and then we will turn it over to the three companies. And if there's any time left after that, we'll have an open discussion. In terms of DAIAA membership statistics, we're at 228 DAIAA members today, and that's up 10 in the last month, which is greater than 50% annualized growth. So, I think the industry obviously is still expanding rapidly. Um, we like new members or members who haven't previously had an opportunity to introduce themselves to the group, to introduce themselves, or if you haven't introduced yourselves for a while, feel free to jump in as well. Anybody want to introduce themselves?
Sure. Hi, my name is Raj Menon. Thank you. It's nice joining the group. I'm a founder of a new crypto project, and it's exciting to be introduced and meet some new folks and learn more about you guys' program. So, thank you, and Lou, I appreciate you inviting.
Sure. Actually, I just am now realizing I didn't have my video on, so it goes. And Raj, am I going to see you tonight at Crypto
I'm gonna
Monday?
try to make it. Yeah, I'm gonna try to make it. I'm
Yeah.
looking forward to it.
Okay, cool.
So
Good.
hopefully I'll see you later.
Yeah, hope to see you there.
Yeah.
Any of our new members or old ones like to introduce themselves? Going
Sure.
once?
Yeah. Uh,
Yep. Hey, Lloyd.
uh, Hi, how you doing? So I've been working closely the past month with two companies that have been doing AI for over 8 years, and they're both backed by Google Ventures. In fact, one of them is headed up by the former head of Google Voice. It's really exciting work. One's called Verkada. They're $1 billion company now. They grew 40% last year. I just a comment on the entire industry. So it's growing so rapidly. Basically, I'm dealing with small businesses, and we're enabling them to use AI without them coding at all, without them even using ChatGPT or because they're too busy minding their business. So we're supplying them with CRM, et cetera, all AI powered.
Awesome. Yeah, doing God's work. Glad you can make it, Lloyd.
Thank you. Thank you.
Anybody else like to introduce themselves?
This is
Oh,
Steve
hey, Steve.
Massour. I just wanted to say hello. I'm a partner at Rains Feldman Littrell and chair the technology practice group there. Um, I wanted to talk about sort of deals on the AI front. It's interesting because the last few years, the investment kind of all got sucked up by the big AI companies. And this decentralized AI space sort of kind of hard to say how it was going to go, right? But it just sort of stayed out of the hype cycle, really, but still kept building, which I think is a practice. I might say it's a practice learned in crypto. Just keep building when the market's down, and I feel like it's developing really well. Uh, and also, the market seems to be headed more towards smaller stage companies, and in sort of a kind of a trickle down effect where the big LLMs aren't that interesting anymore, and now people are looking at some of the smaller companies. I feel like it's a pretty good time to be starting an AI company now.
So that's super interesting insight there, Theo, from what you're seeing, and it certainly makes sense given everything that I'm seeing as well. Anybody else like to? And Steve's hanging out.
I
And
would, I would take that. Hey Lou, how you
Oh,
doing?
okay. Hey,
Is
Charlie.
it? Hey, is it Charlie from Singapore? I actually now in San Francisco. Just finished my AGI summit that last weekend. That was over 15,000 people attending. People from Anthropic, OpenAI, a lot of open source model, a lot of agent company like us were attending as well. It was good to hang out with a lot of AI folks, even watching the World Cup together. So we just rebranded. We're no longer called Coco. Lou, we did our event in New York. We were Coco AI. We started last year. We built our agentic framework called Zyros. We launched that actually 3 weeks before OpenCloud came out. Focused on smart media enterprise for multi-agent coordination. We just rebrand to OpenMax. OpenMax.com is our website, and our new workspace product just fully launched. Super exciting to talk to a lot of the folks in the Bay Area. Actually, it's going to be a pretty eventful week. What do we do is trying to fix the persistent memory issue and a coordinating issue is between all different kind of work agents. Now, pretty much all kinds of the vertical agents are working silos. It's not true autonomous. We're trying to help a lot of small media enterprise to achieve the level for AI autonomous. That's kind of what do we do right now.
Okay, great. Thanks for the update, Charlie. And
Yeah,
where's
well,
the
Charlie,
what?
I liked your booth here. I was
Oh,
there
you went
both
there?
days. I'm about a block
Okay.
away from Palace of Fine Arts, and you had a great, huge booth there. And yeah,
Yeah, I wish I can have time to see you. Like, it was just very chaotic, all the meeting around, and yeah, it was a hectic weekend.
Well, you said in the it was at the Palace of Fine Arts?
Yeah.
Ah, oh, it's a spectacular place to have it.
Mhm.
Well, great. Glad you can make it, Charlie. And then Chris.
Hey everybody, Chris here from Open Matter Network. Some of us have met. I run the biweekly agent privacy and security subgroup. So I'm just giving a shout out. Hopefully we can see some of you there next week on Wednesday at 1 p.m. That's the DAIAA Agent Privacy and Security subgroup. Next week we're having a special guest, Joel Hillier, who's also presenting today. He's going to come in and talk to us a little bit about um, compliance in the age of AI agents. So we're going to learn a bit about what they do today, and then he's going to be able to dive into that a lot deeper. In the agentic privacy and subgroup, we're opening up the dialogue around how agents can act in secure and private ways without giving away all your information as part of what we do at Open Matter Network. We're building the trust layer for secure compute, and we allow organizations to unlock AI collaboration, private data intelligence, and distributed computation without centralized data exposure. Yeah, really looking forward to today's presentation, and I hope to see some of you next Wednesday.
Okay, thanks, Chris. Anybody else? Once? Twice? Okay. We'll then move on to if there are any member announcements. Anybody, any members, want to quickly, announce something that's, going on with, with their business or something that they're seeing in the marketplace. And I'll start with Steve because I know he had an interesting time in Barbados.
yeah. Thanks, Lou. So for folks that haven't met me before, I started Claw Camp. Have AIFI, and I do Health Tech Week every January, concurrent to JP Morgan here in San Francisco. And we're doing something that's a little bit of a hybrid coming up. Well, first, Barbados was amazing. That was just about a week ago. And we did a 2-day Claw Camp. So the Claw Camp's a nonprofit whose mission is to advance personal AI proficiency, and we're doing events all over the world, partnering with folks like Crypto Mondays, need to deepen that partnership, and DAIAA. And so three quick things I'll hit is first update there. I was really impressed by how advanced some of the folks on the island were. This is part of Future Caribbean. If you know Bill Tai, the investor, he has an Act AI, and this is an initiative of theirs to spur innovation and solutions for the Caribbean nations. to create more cohesion and have distributed applications and solutions for things like disaster recovery and finance. Definitely a lot of crypto down in
Sounds
that
very cool.
in that area. So big tie-ins and
You said you had a couple
yeah.
other things?
Yeah, real quick. So coming to New York, August 1st and 2nd, with Alex Fair, Lou, who you met. So we're doing uh, it's basically a health tech claw camp med starter weekend of helping people in the healthcare industry advance what they're doing using agents. So that's a 2-day, and we're kicking it off at the World Trade Center
Sounds
at
very
Asana's
cool.
offices.
Yeah, you should
And
definitely leave links to it about, and what's the last one?
yeah, I'll drop that. And then also, if anybody is interested in grants, we're looking deeply at grants. There's a lot of people like OpenAI that have open foundation grants, looking for other nonprofits and organizations that have been established for a little while that we can partner with to apply for grants and help fulfill our mission and the mission of our partners. So
Great.
if
Have you heard
anybody's
of
in that
DAIAA?
space, what's that? You
Have you
could
heard
be,
of
yeah.
DAIAA?
Yeah, well, we're
Okay,
looking
we can follow up
specifically.
on that.
Yeah,
I'm sure
yeah. Well, I'll mention
Robin
one
will help
thing
us.
just in terms of parameter of we're looking for organizations that are nonprofits with 500,000 to 10 million in annual operating budgets to partner with.
Cool. Okay. Great, great update. Thanks, Steve. Look forward to getting more details about those things. Anybody else have any updates? Once? Twice? Okay, real quick, DAIA updates. The next general meeting, first Monday of the month, August 3rd. The next showcase, third Monday of the month. Oh, so whatever the third Monday of the month is next month. And then we've got the July 29th, as Chris was talking about, is the next agentic privacy and security subgroup. And then next, following that, whoop. The next agentic commerce subgroup is August 5th. And now onto the main course. We've got three. They're each going to present what they do individually, and then they're going to present what they're doing collectively. So this is super exciting to see, the members working collectively to move the industry forward. So Eric.
Thanks, Lou. Hey, everyone. I'm Eric Forst, co-founder and CEO of Blocksee, and I run the Agentic Commerce subgroup. As Lou mentioned, our next meeting is on August 5th. And in the course of running that subgroup bi-weekly for the last year and a half, we've had a bunch of different members who've cycled through who are interested in agentic commerce. And a few months ago, Joel Hillier and Alex Idelson showed up and started showing up every meeting. And we realized that we had a very complementary stack of solutions between Blocksee, Certisyn, and Secret Network that would create something that we're calling the Agentic Trust Stack, or the Agentic Commerce Trust Stack. And so what we wanted to do is just start off with each of us introducing our solution, why we invented it, and the main problem it's designed to solve. And then we'll show you a demo of how all three solutions interoperate. So Alex, why don't you start first and just give a quick walkthrough on Secret Labs and why you started it, and some indication as to how we're using it for this demo.
Sure. So Secret Labs is a TEE company. First of all, happy to be here. My name is Alex Idelson. I'm CEO of Secret Labs. We are a TEE company. I am sharing my screen, right? You can see that.
Yep.
Okay, great. So TEE is one of the major privacy preserving technologies, and it means trusted execution environment. Essentially, a TEE is a hardware-based secure enclave that is confidential, private, and verifiable. It's technology that's developed by Intel and AMD and also NVIDIA as of recently. But it's based on some very common primitive that TEs are running essentially in each one of your mobile devices, right? So it's an area inside the CPU that has its own keys and that even the root user of the device cannot get into. So the goal of the TE is to, one of the goals is to protect information and data from whoever actually has root access to the device. That's one purpose. And the second one is to create digital signatures of arbitrary workloads that can be verified. So with a TE-powered confidential virtual machine, which essentially is just a virtual computer or a computer that can run anything, we get two important properties. First, its memory is protected from whoever owns the hardware, right? Just to give an example, when you're running a server on Amazon or in any other cloud provider, a regular server without TE, whoever has access to the hardware has also access to the memory of your server and can get to your system, right? So that's privacy. That's number one. With this, when people are running confidential virtual machines on my hardware, I cannot get access to their memory, which is great. And the second one is verifiability, meaning that every workload has a digital signature, and anyone can verify what exactly is running. Or to say it more correctly, the owner of the workload can prove to other people what is running there, but by demonstrating the workload manifest, which in technical terms is a Docker Compose file that references certain Docker images. Okay, so we've been doing this for arbitrary workloads and also for AI workloads. So our main products are confidential virtual machines and confidential AI, where an AI server is essentially a confidential machine, a confidential virtual machine with that also has a GPU connected to it. And high-end NVIDIA GPUs also support this memory encryption and verifiability today. So let me just briefly walk through our product, right? So this is the website. Again, we say the infrastructure can't keep secrets, the TEs can. Very easy for developers. We have full agentic support, which I'll show you in a second. The use case here are multiple, as you can see here, and so on. So this is our portal right here. We have, these are my virtual machines. Some of them will be used in the demo today. If I want to create a new virtual machine, it's actually very simple. First, I choose the cloud. Currently, we support our own cloud and Google Cloud. We've partnered with Google, and we can create those confidential VMs on their hardware as well. I choose my deployment mode, single cluster, Kubernetes cluster. I give it a name, choose the size, everything pretty standard. And then I can pick a Docker Compose file from my GitHub or elsewhere. I can just paste it. And this is what essentially defines the workload, right? For the more technical people in the audience, right, this is a Docker image that was built. It's a totally standard procedure. Any application in like 3 clicks can be built in this way. And this image is referenced by its hash, so it's cannot be forged. And if the source code is open, then people can see which source code this image was built from. You provide encrypted secrets, agentic settings, and a bunch of other stuff. We have a very nice integration with Intel here, an additional signature from Intel, and then I launch my machine. Okay, so after the machine is launched, what I can do is a very nice thing. I can actually verify that. Every machine, and let's take the machine in question for the demo today, it has its cryptographic signature. It's called cryptographic attestation. As you see, it's very clear and informative. It's signed by Intel or AMD with private keys that are baked into the CPU in the factory and that no human can know. Okay, so and this whole thing proves the authenticity of the machine. And with this thing, we can actually verify what this machine is running, right? So I pasted the Docker Compose file, the workload manifest of the agent that we're going to be presenting. And I can click the verify button. I clicked it actually, and it tells me 2 things. First of all, this machine is an authentic Intel TDX trusted domain extensions machine. and the machine is built on this source code. This is our secret source code. Secret, the company name, not secret as it's actually fully public, and it's the source code of everything from the kernel and firmware and root file system. All the computer is here and can be checked and verified. And the second thing that this verification says, that this virtual machine is indeed running this particular Docker Compose. Now, if I change one letter here and I try to verify, it will say that, yeah, the machine is authentic, but it's not really running what you think it is running. Right, so think of it, and to me, this kind of makes any load kind of very similar to a smart contract. You can verify its identity. When you send something to Facebook servers, you have no idea what is running in there. What source code? Was it changed yesterday or wasn't it? And so on. With this technology, you can identify and verify the workload you are talking to and you're sending your data to. Okay, so two more quick things that I wanted to show. First is our agentic integration. We have kind of extended the 8004 standard by adding two more properties. Again, for though I'm not going into the detail of what 8004 is, essentially it's a protocol for registering and registering agents on chain. And we've extended the metadata with two additional fields, which are actually what I've just shown to you, right? The TE quote, which is this signature, and the workload. And that means that anyone can actually verify whether this agent is indeed running what it's running. And we've even built this little website here, 8004 Agent Verify, where you can paste the URL of any agent registered on this protocol. And what you get is the verification. So right now, the machine is performing the test. It's saying, okay, let me find this agent, let me get the metadata, let me find where the quote is and the workload, and let me do this magic of comparing and seeing that both match. And yes, I found that indeed it's this agent is running inside a confidential virtual machine, and it is indeed running what you think is running, and this is the manifest. Okay. And the last thing I wanted to show is how this comes into play with AI, right? So besides letting our customers create their own confidential VM, we are also offering confidential AI. And by confidential AI, I mean AI running inside those confidential virtual machines with TEs. This is my little chatbot. What is confidential AI? Whatever it says. But the interesting part here is this. You can see this, it shows verified confidential, and it's actually a verification of the AI machine we're talking to. And here what it says is, okay, that model that I'm talking to, GPT-OSS, it's running on a genuine AMD, in this case, machine, right? We had TDX before, now it's AMD. The workload has been verified. I can check the actual workload. I can check the TLS binding, meaning there's no man in the middle. And I can see the GPU is actually legit. And also there is this additional proof of cloud that guarantees that the machine is in a certified data center. So to sum up, we are a TE company. TE is a technology from Intel, AMD, and NVIDIA, and it allows easily running any workload in a confidential and verifiable manner. And by any workload, I mean what I'm saying, any workload without any limitation, by the way, without any performance penalties. That's also important. The performance penalties may be 3 to 5% depending on the workload, so basically unnoticeable. Developers don't need to change anything in their code, just easily deploy it and run it with all those nice guarantees. And later today, we'll show you how this comes into play in a complex agent-to-agent communication scenario.
Thanks, Alex. Joel, why don't you go ahead and give us some background on Certisyn, and then we'll have some time for Q&A for all of us at the end.
Sure. Thanks very much. Good to be with you, everybody. I'm the Australian living abroad. I live in the Salt Lake City area in Utah, originally from Brisbane, Australia. I have a long background in business advisory services of all different sorts. I've worked globally on large M&As and and in procurement functions, mostly in technology projects for large infrastructure projects for technology that operates at the sovereign layer. And I've had a lot of experience in trust relationships, I guess, as a result of that, where people need to verify claims that people make. And so Certisyn is a claim verification or a verification infrastructure company specifically aimed at helping organizations increase the velocity of a deal or any type of trust transaction. And that includes claims of individuals and their specific backgrounds, or claims of entities, or claims of technology, or any type of claim essentially. So Certisyn is built to take claims or extract them from things that people say or produce, and then invite them to provide the evidence that supports that. So it's essentially a reconciliation process between the claim and the evidence. So different kind of due diligence. We don't re-prosecute someone's financials, as an example. When we're trying to verify them, we expect that the financials are properly prepared, but that the claims that the financials would then make can be validated in a way that we triangulate that with as many different elements that we can in terms of evidentiary stacks. So lots of words about claims and evidence and so forth. It's a process that includes lots of data gathering, but we don't necessarily hoover up all the data. We like to keep it where it is. So we send compute and capability to where the data is typically. That solves a bunch of different issues in terms of, I guess, where data residency is of a particular priority for an organization, and sovereignty. We make sure that we respect those boundaries. So we can take any type of claim, whether it's from an audio or a video or a PDF document or a PowerPoint presentation or just a URL, even an API call or an attestation, and we can extract the claims that it's making and then do some fancy work inside to figure out how that operates. So verifications essentially not an AI function for Certisyn. We use AI at the front end to normalize data and to understand what's being presented. But after it's been presented, we do some forensic analysis. So there's some significant proprietary tools that have been developed for forensic analysis as well as security analysis to detect where the information came from, what format it came in, and whether there's been any tampering or any layering or any other types of synthetic nature introduced into that evidence. And so that particularly is important given the environment that we live in today, where there's, lots of opportunities for people to make things that look authentic. So Certisyn has developed some patent pending technologies, in fact, 148 patents pending in regards to what data comes to it and how it's processed internally. So let me show you quickly just a couple of things that we would sort of develop as regards to the way that something happens. So there's lots of ways we have to verify information. So let me just quickly jump on a screen here and show you a little bit. There's one particular one is called a public signal verification. So we can take voice as a prompt, paste information or documents uploaded, and we can put in there the name of an entity that we want to do some sort of diligence task on, and do a pre-screen before we enter into a trust relationship with them. And then there's many other types of verifications. We have quite a variety of them, whether the person is voluntarily being diligenced or whether they're doing something that they haven't really requested, and so somebody's doing some diligence task ahead of an invitation to be engaged in some sort of commercial transaction. So we do many of those things, and you'll see some of that today. But we have a variety of entry points. This is fully built. It's been ISO certified under 9001 and 27001. The system actually manages itself against 33 global regulatory regimes. And because verification is what we do, we felt it prudent to manage ourselves to the highest possible standards globally in regards to what people are promoting themselves. So we can sell verification as a service where people have been certified under a SOC 2 Type 2 or anything like that. We can actually do a continuous scan of their environment and confirm agentically that they maintain that posture after they've been certified. So there are lots of different tools that we do have. Let me just show you one quick version of a type of verification that might be useful to show. It's called a security scan. And let me just pull up one here so I can share my screen again. 1 second. Sorry, we're getting close to the half hour here. So in Certisyn, there are actually 7 front doors, depending on what type you want. We have Certisyn Lumen, which is for managing data center operations and the types of things that they might need verifying, like their clean compute hours and so forth. We have Certisyn Litigation, which is a platform for it's legal tech, essentially. The forensic analyzer and the security scanner it lives in different platforms as well. So let me just show you what I'm doing here on.
You're not sharing the screen, Joel.
Yeah, there we go.
There you go.
So Certisyn Bastion is the security scanner. It's its own enterprise within here. So I'm just going to show, this is a company that was scanned just recently, and it provides a rating on their URL. So this company's URL is scanned, but then it goes and provides a whole report that actually shows them how to fix the issues with regards to their platform. And we have a tool called Certisyn Presidium that operates inside here that agentically will go and remediate all of these things. So it will detect a number of things, including where their technology stack lives. So if they're hosted on Cloudflare or something like that, and it will go and say, according to these regimes, these are the top things where your platform or your URL is at risk. It will detect from the URL, like certisyn.com is my marketing site, but it will detect that I have a code base that lives at app.certisyn.com or me.certisyn.com or members.certisyn.com, and it will go and find all the weaknesses and vulnerabilities in those, and then provide feedback to the operator as to how to remediate all of those things. And then if they give the authentication, the agent can go in and actually do that, and then leaves behind a sealed certificate saying cryptographically, here's the derivation chain of the things that we did, the things that we didn't do. And it looks there, like this one, the discovered attack surfaces for this company, and then all the different things, and leaves behind the evidence that they can figure out the provenance of that. So there's a lot of things that Certisyn does, some of it agentically, some of it with just mathematical compute. The actual verification itself is not AI driven, hence it can become deterministic and allow us to provide full replayability of everything that was done. So that's a little bit about us.
Thanks, Joel. So let me just give a quick overview of Blocksee, and then I'll show you the demo we put together that shows our 3 technologies interoperating. So a lot of you may remember Blocksee from a few years ago when we launched as a Web3 CRM to manage NFT communities. And we still believe in the utility of NFTs or smart contracts as a way to verify provenance as sort of the core problem that NFTs were solving. And so we've made a few pivots with Blocksee. And last year we were using our payment platform, PayPangea. So many of you know Matt Kotnick, our CTO, who also runs PayPangea, which is a stablecoin infrastructure for payments and wallets, and also being able to give SDK wallets to agents. And so in the course of looking at how we could, help companies bring data online for payments and to sell their data, monetize their data, use blockchain for provenance of the data, we realized there was a lot of fraud in documents, and that there's still a massive amount of fraud in the mortgage industry where you have mortgage brokers that continue to go in and change FICO scores and PDFs to get loan approved, for example. And we were already building software that we call Grace Point Solutions, which is a live software to help charitable donations, to help manage gift in kind charity by taking hashes of the inventory, storing those in Merkle tree, batching in Merkle trees and storing those hashes on chain as a way to prove delivery. And so in seeing this problem with documents, we realized, we can really help verify documents. And as long as we're putting documents online and on chain to make them verifiable and prove the provenance of documents, well, we can just have people sign them as well and have a competing product to DocuSign. So the new Blocksee, as you can see here, it says sign, verify, and prove understanding. We have a patented gating mechanism called proof of understanding, which works like a notary does in Europe, where before the signature can be applied, the signing parties have to take a quiz and prove they actually understand what's in the document in order to be able to sign it. So it's a nice little feature that can also apply to agents. But Blocksee is now this new platform that let me show you what it looks like under the hood that lets you store and manage documents and sign documents. So you get a dashboard that shows all of the documents that have been signed, and you can also look at all the documents that have been sealed. And when you make a new agreement, you have two options in how you want to create a document. You can use our encrypted cloud if you want to have all of the AI features to run proof of understanding, to analyze the document and apply the fields, the kind of stuff you're used to with DocuSign. Or you can use our zero custody mode, where the document never hits the cloud, remains entirely in the custody of the signers. We're just taking cryptographic hashes of the document and the signatures, storing those on chain. And each party is responsible for storing the final PDF on their own machine, sharing it with the other parties. And you can go back into the dashboard and see a reconstructed document, but the document never goes into the cloud. We also launched an MCP server, so you can give the powers of document signing and contract management to your AI agents. And so the agent can seal documents, verify them, but it can also create agreements, create an agreement from a PDF or from a prompt, let you manage the agreement, see the status of them, and get the agreement details. So in the demo we're about to show you, we're pulling the create agreement from a prompt power from the Blocksee MPC server and the get agreement details in the demo. And the final settlement layer is PayPangea. So if you all haven't seen PayPangea in a while, it's now a crypto bank. It's basically like Mercury, but it sits on top of a network of 160 banks and allows you to have a real ACH number, routing number, bank account with a real bank in near wherever you live in the world. But the bank never holds your funds. Everything converts to USDC, and you self-custody all of your crypto in a self-custody wallet that is powered by PayPangea, or you can offload it into your MetaMask, whatever you want. So with that said, let's share the demo. Oh, one other thing that we developed to support this architecture and this infrastructure is the Consenti protocol. So this is an open source protocol for agreements that is under MIT license. I'll put this GitHub repository address in the chat, and if I can find it, put it in right now. Chat icon's not showing up. Here it is. So putting this in everyone chat. So Consenti basically enforces terms before transactions. I noticed with X402 there was a lot of transaction volume happening, but no one was necessarily putting agreements in place. So this is meant to be a companion to X402. It actually issues a 409 error. So you might want to call this X409 protocol, but it basically says if there isn't an agreement in place and I'm an agent selling stuff, I can't accept your payment. I can't even get to the X402 protocol if we don't have an agreement in place first. So love to get people's feedback on this, have you using it, open source protocol. So let's go into the agentic trust stack with a few slides and then show you the live demo. So what we're going to show you today is how you can have a secret VM as the execution environment, a trusted execution environment. The Consenti protocol to find terms, see if they're in place, verify if the terms exist or if they need to exist. Use Certisyn to verify all of the claims being made by the selling agent. Have Blocksee spin up agreements that are sent to humans for signatures. And then the pay-Pangea settlement is only allowed to happen once the contract is in place. So as I mentioned, under X402, there are, this is through the end of June, this data, there were 153 million transactions that did $40 million.
Hey, Eric,
Yeah.
if you click on slideshow, it'll take up the whole page.
Yeah, sure. Happy to blow it up. So, so 40 million settled. So an average transaction of 30 cents per transaction. These are for API calls and data. Lou, you had a woman earlier in the year who presented a lot of this data that she was
block run.
block run, yeah. And then she also creates a nice interface to set up X402. This was just the latest data I pulled from Dune, just doing a Google search. So as I mentioned, this stuff is happening. Tons of agentic transactions are going through, but there's a lot of stuff missing, like what terms govern the transaction, what are the usage rights, the rate limitabilities, liability, data usage policies. Nothing's necessarily presented. And, 1 30-cent transaction, maybe there's not much liability there, but, if that agent does that 100 times or 1,000 times, what is your exposure? Who authorized the agent? Like, how do I know if that's not someone spoofing the Blocksee brand and just pretending to be Blocksee and coming in to an agentic marketplace and then just wanting to spoof people and scam people and take their money? And what can anyone prove later on? Like if I'm in a regulated industry and if it's HIPAA or finance, and I need to prove and show auditability to all the transactions my agents made, how do I show that? What are the agreements that they made, and how can I prove it? So this agentic trust stack fills these gaps, it answers these questions where when payment protocols are moving money between agents. Many of you may not know that in 2000, the Uniform Electronic Transactions Act, UETA, and e-sign became law in place by 49 of 50 states. Can't remember which one is not is the holdout, but these were the laws that were designed for document signing, but they were they had a lot of foresight when they put this together, in that they realized electronic agents may autonomously make agreements with each other. They were literally seeing 20 years ahead to the age of AI and agentic AI. And so if you launch an agent that makes an agreement with another agent, you're legally binded by that. And so it'd be a lot better for there to be an actual agreement in place, which is why we have Consenti and why we have Blocksee. So within agentic commerce, within agentic transactions, we have these payment protocols, we have communication protocols, we have tools. Identity is kind of emerging, and Alex just showed you that, with ERC 8004, you can get very good identity just by using the secret trusted execution stack, which is what we've done. For the demo, Visa and TAP or other identity protocols. Pangea has payPangea has Pangea ID, which allows you to do KYC, and it taps the sub network, and then it creates a hash of your identity KYC verification on chain. So you don't have to do it over and over again. And Joel has an identity protocol within Certisyn. So there are all kinds of identity protocols, and you can stack them together depending on how much proof of identity or KYC you need. So there are 5 layers in this demo, answering 5 questions. Secret VM, is the agent running the code it claims? Consenti is saying, what are the terms that govern this transaction? Are they in place? Certisyn is saying, who checks the parties running the commerce and verifies that their claims are true? Blocksee is providing the binding commitment, and then payPangea can not only settle the transaction, but it can also, store information cryptographically through smart contracts to really provide receipts for the whole stack. So you're about to watch all of these things interoperate, and this flow chart really explains what's about to happen. Basically, the Acme Procure bot that you're going to see, is looking to buy document signing services, and we're just assuming they found each other in the 804 marketplace. But the Blocksee sales agent isn't allowed to sell anything unless there's an agreement in place. So that's the Consenti X409 protocol. So that's going to fire off, look for an agreement. If it doesn't find one, it's then going to generate one. And there's two different ways it can work. You can have the dotted line where it will actually generate an agreement for signatures, which is what we show in the demo. But it could also just be a terms of service that's hosted on the well-known agreements directory, which is part of the protocol. And one agent could just say, you know what, your terms of service are there. They look good. There's nothing in them that violate what my legal department has said I'm allowed to sign or not sign. So I'm just going to go ahead and sign it. And the whole thing could move forward without a human in the loop. You can run it either way. And so that's the dotted line is just showing the human in the loop, and we're going to run that. And so then once all the signatures and verifications have taken place, everything progresses to where the payment gateway is opened. Like the payment will be allowed to be made. We're not actually going to execute the payment in the demo, but we're just going to bring it to the point of payment with all of these verifications happening under the hood. So let me just show you the live demo real quick, and then we'll have a few minutes for questions. So just going to click the run demo. And so here you're seeing the secret network is engaged. The Blocksee sales agent is running in a trusted execution environment. The Acme Procure bot is requesting the professional API access for Acme Corp, and it sees that it's a $60 a month transaction. Before I narrate the rest of this, Alex, why don't you describe the protocol event log here that is being produced by Secret Network. And then you can see the log is showing chronologically all the steps in this transaction, which is now paused because it's waiting for signatures.
Sure. So in this scenario, we have two agents actually talking between themselves, but before they start talking, they verify their identity using the TEE attestation protocol that I showed you guys in general during my presentation. So you can see that here before starting the whole process, the Blocksee sales agent is verified, right? So again, we see that it's genuine Intel TDX, that it matches a certain artifact template, and then the TLS fingerprint is also verified, right? So in full solution, the workload fingerprint could also be matched against some golden values to see that, okay, this is exactly the source code we are expecting to talk to. And then later, when we see this process continue, if Eric, if you scroll down just a little bit, so we see that Certisyn agent is also being attested, right? So the Blocksee agent, before talking to Certisyn, it verifies that the entity or the machine is going to talk to is indeed a genuine Certisyn agent that can be trusted. So here there is mutual trust established between those two entities because they can verify each other's workloads and compare them to some previously known values. So they know who they are talking to, and they are and therefore they are sure that they can securely send the information, and then the responses they receive are correct and have not been tampered with.
Exactly. And so all of those verifications are happening in seconds. You can see the log here, the timestamp, and then well, it starts here with the Blocksee agent, and then the procurement agent seeing it a few seconds later. Then wanting to initiate the transaction, but getting a 409 error, which says agreement is required because the selling agent is running the Consenti protocol. Because Joel and I initiated this last night, it's saying here that this party already committed on this server during an earlier run. So what that looked like when we ran it last night is we didn't, before we put an agreement in place, is it said, hey, there's a 409 error. The agreement is still required. There's no prior commitment on file. So we practiced this last night and went through and ran it all the way through with the signatures. Joel, we could do that live right now. We each have a new agreement that was sent to us here in the top of our inbox. So Joel, I'm going to go ahead and sign the brand new one that was just sent to me 3 minutes ago when I started the demo. So
Yep.
now I've got a review and sign document message in my inbox. And so this is now the Blocksee document signing platform. I can, use pre-configured signatures or sign one if I want. I'm just going to hit the sign and submit. So I now have that document. Joel, you're going to do the
Just
same.
sign mine.
You just signed yours, and so
Yep.
now you'll see the gateway open up. So now both parties have signed, and now it's moving the process all the way through to payment can be requested, so that there's now a PayPangea payment link generated once these gates have all been completed. So, I won't keep going on since we only have about 6 minutes left and want to leave some time for questions on what we've just presented here.
Look, this was super interesting. I'll start with a couple questions and open it up to everybody. First, what was the biggest challenge you guys faced in stacking these elements?
This was actually pretty easy to set up. The trusted execution environment in these secret VMs was super easy to run. So, as a vibe coder, as someone who built, the protocol, built all of this tech, just vibe coding in Claude Code, this was just an incredibly friendly user experience. So once Consenti was live, and once the Blocksee MCP server was live, we just needed a couple of calls to test this stuff and get it set up and get some of the bugs worked out. But I would say it was a overall pretty easy experience. Alex, Joel, do you want to comment on that?
Sure. Yeah, I think there's a lot of uh, credit that goes to the AI tools that we use to help us with some of these things in problem solving. What was required in the first instance to figure out how to connect them. But yeah, I think it's a simple process for sure, and it lends itself to all sorts of other opportunities. So whether it's Blocksee or Secret or Certisyn, there are other organizations that I'm presently in conversations with where we're connecting technologies together in a similar fashion. And it's equally simple and also extraordinarily powerful in terms of the additional benefit that you get. So not hard to do, but the upside is major.
Alex,
Yeah.
any thoughts on that?
Yeah, I mean, to me, it was just very cool to see how more workloads are being deployed and how very meaningful apps are very easily being deployed on this. I don't know if you guys even use. We have a special skill of Secret VM. I'm not sure you use them, but that might even make the process even simpler. And actually, based on your feedback, I made some changes, some updates to this skill to make the process even smoother. But again, in general, Dockerizing any workload is easy, and with today's tools, you don't even need to know the words. You just say, please deploy that to a secret VM, and it would say, okay, give me your, log into the system, and it will do all the rest.
Wow, that's great. Are there next steps that you guys have discussed?
Yeah,
Yeah,
so
get
go
production.
ahead. Go ahead.
Yeah, I think the next steps are taking this to production big time. So we'll need to figure out the details, but yeah.
Exciting
we
stuff.
have a signed MOU for commercialization, so that's the next conversation for sure.
Nice. Dimitri? I'm sorry, Eric, did you want to add
No,
something?
go ahead, Dimitri.
Okay, hi guys, amazing stuff. So that's my question exactly. So what would be the use case? Let's just say if I run a business and I guess everybody's deploying agents, we're deploying agents to service our clients and customers. So would I use your system to make things legal, proper, verifiable and verified, both for us and for them? That's question number one. Question number two, those legal agreements, wouldn't you imagine that somebody might want to take a look at some point, like human would have to look at the agreement and review, and then lawyers might need to get involved in how you
Absolutely.
see pairing it. And the third question is about a token. What token do you use? Is it a secret network? Is it a secret? I'm just curious what token you use in processing all this. Thank you so much.
Alex, why don't you take the token question, and I can talk about
Yeah, I'll take the first one and the second question. So to your first question, Dmitry, if you're running agents and you want your customers to trust those agents, you may achieve that by deploying those agents in a TEE, maybe after an audit by a reputable company, or if you're opening up the source code, because then the customers may be sure that their data is not going anywhere it shouldn't go, and also that the cloud service provider cannot peek into the data or still steal the information. So that's question one. Regarding the token, so this product is actually an off-chain product. We do, as a chain, we do have a token called Secret Token. That's from our legacy layer 1 blockchain, also based on TEs. But this product, both confidential VMs and confidential AI, they are essentially off-chain products.
And I would say that the main user, the user profile that we've identified are chief legal officers, compliance officers, anyone who sees or is worried about their company launching agents out into the world that don't have control and governance and want to have a governance system in place. And as we showed, we do allow for the human in the loop if you need it. So we just, we showed agreements being sent to people to review the agreement and sign it before the payment was allowed. So that is exactly what we just demonstrated here, that gating, that human in the loop control is available through this process. Or if you want to let your agents be more autonomous, at least they'll be putting an agreement in place that the AI agent is saying, hey, this agreement doesn't have anything that is offensive to what my legal department has said are our standard terms, so I'm going to go ahead and sign it. If you want to give your agent that much control. But we give both options. And then I'm just showing you here the Certisyn verification certificate. So anyone who is operating with ISO, SOC 2, or GDPR, frameworks should be using a system like ours. Otherwise, you have all these potential violations or inability to prove what your agents are doing if you don't have this type of system in place.
And I have one quick follow-up question then. Do I understand it correctly that I deploy the agents, like the agents that we produce, I deploy on your network, correct?
Exactly. So my agent is deployed to GitHub, and then it was very easy to just have this secret VM, this virtual machine,
Right.
ingest my agent's GitHub and now run it in this trusted execution environment. So third parties can say, okay, I don't have to worry about the metal or the cloud or some, black ops, security agency trying to spoof things. I can absolutely verify with certainty the identity of this agent because, inside here, I can take these attestations, these RTMR identifiers, which are unique to this instance, and now I can publish them on Blocksee. So I can prove that, okay, I'm running a Blocksee company agent because there's no other way for this attestation for me to publish it under my domain that my company owns. So this is a really key layer to verifying the identity of any agent that you're going to do transactions with.
Yeah. And that
just a quick addition, you can think of those confidential VM just as a cloud service provider, like a cloud provider, like is similar to Google Cloud. You need to deploy somewhere, right? You deploy your agent somewhere, so you can't deploy them on those little virtual machines.
Right.
Or they can be big, they don't have to be small.
Yeah, makes sense. This is awesome.
Yeah. And those elements that you're talking about there, Dimitri, and that we've just shown, I think as regards to verification, Certisyn is the part of that actually has no real piece of the transaction directly. It's actually verifying all the other pieces. So it's the independent third party in the room. And so that document that you're seeing that Eric's got up on the screen, it shows how everything was transacted without actually being part of the transaction. So it's saying, I found the agent, I confirmed what its parameters were, and its operating agreement says it's allowed to make this transaction. and then it does so. We confirm the transaction itself. Then we confirm all of the pieces from start to end independently, which is cryptographically sealed and deterministically provided in that derivation chain root. So all those elements are replayable without actually logging into Certisyn itself. So you just get that chain root hash, and then you can see all of those things without actually having us in the room. So that's the full deterministic independence that is required regulatorily now.
Yeah, very cool. And if I want to talk to your organization, who do I talk to? Do you have any one person, or I should talk to all three?
You can start with any one of us that you like to, and we'll all represent each other. But we are looking at how we can turn this into a joint venture and deliver
Awesome.
this combined stack in an operational way. Yeah.
Thank you. Thank you.
Yeah. And our email addresses are inside the end of that presentation, which will be made available. But you can find me on LinkedIn if you're not already connected with me, Dimitri.
Yeah. Here's our email addresses if anyone wants to grab them.
Okay. Well, thanks, guys. That was terrific. And
Well, thanks, Lou, for having us on.
and have a happy Crypto Mondays, everyone.
Thanks, everybody.
Thanks.
Thanks, everybody. Thank you so much.
Bye.